Okay, so at this point we know how to do all of the operations: multiplication, division, some roots, some exponents, and lastly addition and subtraction. So we can do it all for fractions. The next step is to sort of go back and make sure that we can also do it all with mixed numbers, right? Mixed numbers are sort of combinations of whole numbers and fractions. And we need to make sure we can work with them. We'll sort of see them, so we need to know what to do. We're going to start just like we did with sort of regular fractions with multiplication and division. And the strategy is going to be, I kind of have some of this stuff previewed out already, right? So for multiplication and division, what we're going to do is we're going to convert to improper fractions, right? So we're just going to do a quick conversion, right? Get sort of a larger value in the numerator over the denominator. Excuse me. And then we're just going to proceed normally. Then we're just going to do our regular routine for multiplication and division. So this is really just sort of one extra step, this one conversion step, and then we just kind of do what we've been doing. I had to sort of pre-plan a couple examples because you have to sort of work extra hard in this case to sort of get some numbers that will cancel out. Hopefully. I guess if I screwed it up, I'll probably just make another video and I won't post my screw-ups. In any event, so let's try something like 2 7/9 multiplied by 6 3/10. So let's see what we've got. The temptation here, if you were just sort of doing this cold without any kind of like prep, like explanation, you're going to maybe want to try to do 2 times 6 and then 7/9 times 3/10. Definitely don't do that. That's not going to work. So don't do stuff that doesn't work. That's my advice. So what we're going to do is convert them into impropers, right? So for us, right, that's going to be sort of 9 times 2 plus this 7 all over 9. We'll multiply that by, right, 6 times 10 plus 3 all over 10. So once we clean this out, 18 and 7, so it's going to be 25 over 9 for fraction number 1, and then 60 plus 3, 63 over 10 for fraction number 2. So the real values we're working with here, 25 over 9 times 63 over 10. Again, the kind of limitation for improper fractions is the numerators just get so big, it's not totally, it's not quite as easy to sort of estimate the size of the numbers. We could guess, right, 2 7/9, this is kind of almost 3, a little less than 3 times, 6 3/10, a little bigger than 6. 3 times 6 would be 18. So our final numbers here are probably going to be in that ballpark. We're not going to hit 18 kind of right on the nose necessarily, but that's going to be my guess. So just like in section 4.3, once we get these fractions laid out, we need to look for any kind of common factors to cancel away. So one thing that stands out to me, 63, right, is going to be 9 times 7. I won't break down the 9 because I have another 9 right here, so we'll just use it. 10 would be, right, kind of 5 times 2, and 25 would be 5 times 5. So we can cancel 9 with the 9. That would kind of leave us with a 1. We can kind of put that in as a placeholder. And then we can cancel 5 and 5. So this would leave us with what? 5 times 7 over 1 times 2. So that's going to be for us 35 over 2. And then the final step here is, right, once you have sort of an answer, an improper fraction that's reduced, what you want to do is convert it back into a mixed number, right? So if we start with a mixed number, we should sort of convert an answer in the same form. So convert this back. So not too bad, right? 2 into 35. What are we going to have? 17 and a half, right? 2 times 17 would be 34. So that's going to be 17 and 1/2. I kind of estimated where we would end up around 18. So a little bit under that, but that's totally fine. Not a big deal. So we're definitely in the ballpark. That seems like a pretty reasonable answer. So we'll go with that. Couple shakes on the table from the the dog scratching. Always something going on in this math house. Example number 2. Let's do a division example. This is going to sort of follow the same basic strategy. Do a conversion first, convert it into an improper, just sort of both of our values, and then we'll just sort of do the division as normal, right? And to do our division, we have to do the sort of keep, change, flip routine, but you know, one thing at a time. So let's convert first. This is going to be 15 times 2 plus the 2 up top, all over 15. We'll divide that by 9 times 2 plus the 2 up top, and that's all over 9. So these are going to get us to where? 32 over 15 divided by 20 over 9. So that's our division version. Right, whenever we have fraction division, what we'll do is keep that first fraction the same, but then we're going to change from division to multiplication, and then we're going to do the reciprocal, right? We'll flip that second fraction. So this 32 over 15 times 9 over 20 is sort of what we're going to end up with. Look to cancel, just like we were doing before. Factor and cancel. We could do 9 is 3 and 3, 15 is 3 and 5, 20 would be 4 times 5, 32 we could break a bunch of different ways, but if I've got a 4, let's do 4 and 8. So I could do 3 cancels 3, I could do 4 cancels 4. Let's kind of regroup, see what we've got. 8 times 3 over 5 times 5. So 3 is out, 4 is out. That's going to be 24 over 25, right? No common factors there. And I guess that itself is a proper fraction. So we end up something here. We sort of started with mixed numbers, and we sort of end up with a proper fraction, which we can't convert back into a mixed number. That just sort of is what it is. It's our kind of final answer. That answer seems pretty reasonable. I mean, this is sort of 2 and change divided by 2 and change. In theory, right, 2 over 2 would be 1. These guys are obviously a little bit out of sync with each other. If we look at the fractions, they're slightly different. So it would make sense for us to end up with something that's close to 1, but not quite there. 24 over 25 definitely kind of fits that description, right? 25 over 25 would be 1 whole. 24 over 25, just a little short. So that's multiplication and division with mixed numbers. So just this sort of one-step conversion, and then just do a process we already know. Just do the regular multiplication and division.